This video reviews for the Chapter 2 test. In the first section of Chapter 2, we learned about inductive reasoning. Based on these observations, we started with 1 square, added a row of 3 to get 4, added a row of 5 to get 9. Our next step would add a row of 7 to get 16. In number 2, we see we have 8 squares, then 12, then 16. The next one is going to be 20. For number 3, the quotient of two whole numbers is a whole number. So 3 is a whole number and 2 is a whole number, but if I divide those, I don't get a whole number. So 3 and 2 are a counterexample for this conjecture. Number 4 asks us to describe a pattern in the numbers and then write the next number. So our pattern here is that we're adding 111. Our next number will be 557. For number 5, we could describe this relationship as adding n plus 1, plus 2, plus 3, plus 4, plus 5. Perhaps you wrote sequential addition. We're going to add 6 to the next number, or to 18 to get the next number, which is 24. For 6 and 7, number 6 is true. If we added these two measures together, we would get 180, and that's the definition of supplementary angles. And number 7 is false. While most two lines intersect at most one point, if we had parallel lines, they're intersecting at every single point along the line. For number 8, the converse of if an angle measures 30 degrees, then it is acute. We switch those around, and the converse is if an angle is acute, then it measures 30 degrees. This is sometimes true, but not always true. There are other acute angles than 30 degrees. So we cannot write a biconditional statement because both of these are not true. For number 9, the converse is true this time. If two angles have a sum of 180, then they are supplementary. So we would write our biconditional statement like this. We get rid of the ifs and the thens, and we have our hypothesis, if and only if, our conclusion. We can do that because the conditional and converse are both true. So for the next section, we're using this conditional statement. If you're a soccer player, then you're an athlete. Number 10 is the contrapositive, not the conclusion, then not the hypothesis. Number 11 is the converse. These have just been switched. Number 12, this is the inverse. For 13, the answer is A, if-then form. And we're supposed to circle the hypothesis and underline the conclusion. In 16, the first thing we do is use the distributive property. Then we're going to add 5 to both sides. Then we can subtract 9x from both sides. And we're going to use this idea of the symmetric property to switch around these equivalencies and get 7 is equal to x. For 17, the reflexive property says that the measure of angle B is equal to the measure of angle B. It's equal to itself. In 18, the transitive property says that if CD is equal to GH and RS, then GH is equal to RS by the transitive property. For 19, if we add 14 to one side, we add 14 to the other, and we should get 17. For 20, the symmetric property, we just reverse the order. For the substitution property, we replace the measure of angle A with what it's equal to, and then we multiply to get 135 degrees. And for 22, to get from 45 to 15, we have to divide by 3, which is the same thing as multiplying by 1/3. So for 23, the angles 1 and 2 add together to form a straight angle, so they should add up to 180 degrees. And we can see that 47 plus 43 adds up to 90, but not up to 180. So this one is false. In number 24, they're telling us that 1 is 47 degrees and 3 is 47 degrees. These are vertical angles because there's two lines that cross, and we're looking at the opposites. So this one is true. 25 says 1 plus 3 is equal to 2 plus 4. Well, 2 and 4 are both bigger than 1 and 3, so this one is not true. For 26, we're looking at 1 plus 4 and 2 plus 3. They're both 180, so this one is true. 27 is a proof. The first statement is given that angle 2 is congruent to angle 3. We know that 3 and 4 are congruent because they are vertical angles. And for number 3, you could have put substitution or transitive property, we're basically saying that A is equal to B and B is equal to C, so A is equal to C. Or you could think of it as replacing angle 3 with what it's equal to. Both do the same thing. 1 and 2 use that same idea of vertical angles and the same idea of transitive property. Since 2 shows up in both of these equivalencies, 1 is going to be congruent to 4.